Hello, and thank you for joining the webinar today. We're going to give folks a couple more minutes to log in, so we'll be starting real soon. For those of you joining us today, we're going to wait probably one more minute or so for more folks to join, then we'll get started. Okay, let's get started. Hello, everyone, and welcome to today's Better Buildings webinar. This webinar is dedicated to bringing you the latest actionable insights from leading industry experts. These webinars are a chance to explore topics, technologies, and trends that affect your organization, as well as efforts to accelerate energy efficiency strategies and reduce costs. So today's webinar is called Value Stacking: Financial Metrics to Fully Assess Energy Project Impacts. So before we dive in, however, there are a few logistical items that we need to talk about. You may have heard, but we are recording today's webinar, and it'll be archived on the Better Building Solution Center. And so you'll get an email following up after this session when the slides are up and available. Secondly, as attendees, you're in listen-only mode, meaning your microphones are muted. If you do experience any audio or visual issues throughout the webinar, please send a message in the Q&A box located on the bottom of your Zoom panel, and our tech support team will reach out to you. So my name is Paul Lamar. I'm one of the technical account managers under the Better Plans program. I'm with Oak Ridge National Laboratory, and I'm your moderator today. My background, I've been with the program as a technical account manager since it got started back in 2009, and I work with approximately 20 partners within the Better Plans program. And I've been doing that for quite some time. Let's see. So we want to go over our agenda next, and so after we do a little bit of welcome and I'm going to kind of give a little bit of background on this topic, this value stacking financial metrics. Then we're going to have a few polls where we want to get your opinion, your thoughts on things. And then we're going to introduce our speakers, and they're going to tell you how they do this. And so that's when it gets really, really interesting. So we're glad you joined us today for that. So now I'm going to just take you through again some of the background information, and a lot of this background is based on a working group that we held within the program, where our partners joined us to talk about how they do their financial metrics for more complex energy projects. Next slide, please. So what we learned from this working group was that and we kind of knew this going in, that simple payback period has some pitfalls in terms of financial analysis. It's really good for quick hit, quick return energy projects. But if the project has more involved features like other benefits outside of energy savings, or takes more time to recover your investment, then it may need a different approach. And so what we talked about in the working group was a more robust, structured approach using kind of a framework to evaluate more complex investments. And so one of the things, the hallmark of these more involved evaluations, was using the time value of money. That involves using, discount rates to look the present value, to bring everything from the future, bring it back to the current in terms of financial terms. Secondly, we were looking at both techno-economic analysis and life cycle cost assessment, looking at the principles of those and applying them within this framework. Thirdly, we wanted to make sure that we capture any non-energy benefits, things like production impacts, savings in labor and materials, anything that. Sorry, my internet just dropped off there, but it sounds like it's back.
Yes, it is.
Okay. Um, so we were just talking about the structured financial analysis, and can we reshare the slides, maybe?
The slides should be up.
Okay. All right. So let me do this on my end. Okay. So just give me 1 minute. Okay. And so, and the final thing is, after we get the non-energy benefits included, is if it's relevant to incorporate some way of valuing emissions reductions. Some organizations use an internal carbon price, or maybe look at the emissions reduction in terms of a marginal cost of emissions reduction. These are two ways that folks do that. Next slide, please. So this approach, we've kind of laid it out in 3 steps. The first step is to structure the analysis, and that involves using, a discount rate that we mentioned, and then look at the life of the asset. And so it may be that the asset is longer than 10 years, but that the term of the evaluation is held to 10 years. And then again, using that some internal cost of carbon or some other way of valuing emissions, if that's included. Step 2 then is to get into the value of those non-energy benefits and try to quantify those as much as possible, and making sure they can be justified to your financial team.
Paul, do we have you back? Due to some technical issues, we can go ahead and move forward with our polls while Paul is back, since he's unable to. Oh, Paul,
Oh,
are
sorry about
you?
that. Yep, I only got a couple more slides, and then we can turn it over to.
Great.
Okay. Sorry about that. Okay, now finally, just to briefly review these three steps to determine your structural parameters. Again, we need to look towards a present value type of analysis. So you might need to find out from your financial team what types of parameters, whether they use net present value or internal rate of return, or maybe it is simple payback period with other considerations. Find that out in advance, find out what the critical issues are, the life of the asset, things like that. And then again, if there's any way of evaluating emissions or any other impacts, make sure all that's known ahead of time. Next slide, please. Then once we've done that, identify what these options are. And so ideally for any project where you're looking at, you might have alternatives. And we talk about the pillars of savings. It could just be an energy efficiency option. Maybe there's an electrification or a way of fuel switching as well. And it probably makes sense to evaluate all those options in terms of their technical feasibility, and then try to evaluate the economics or the financial returns. So to compare how you do it now, your baseline system with these alternatives, looking at their operating costs, the capital costs, any energy cost savings, and any other non-energy benefits such as productivity, labor, material, anything that can be quantified and justified as a savings over the way you do it now. And then put all these into that structural framework so that you're comparing them on an apples to apples basis. Next slide, please. And then the final step is to apply the discount rate to bring all the cash flows back to the current year, and then determine what that financial return is in terms of how your organization looks at that evaluation. Maybe it's on a internal rate of return, net present value, or other financial metrics. And then make sure that those non-energy benefits are in there. But if they can't be quantified, then include those qualitative benefits. And we'll hear from our speakers about ways to do that. But basically provide as strong as justification as you can. And then identify of those options, identify the alternative with the most attractive financial return and present those results. Next slide, please. So we do have some products coming out of this working group, and they'll be available soon. We do have a primer already available on the Solution Center for Non-Energy Benefits. I think it's called a fact sheet on non-energy benefits. We have a similar one being developed for structured financial analysis, which is under review. It'll soon be out there. And the structured financial analysis spreadsheet tool, which is ready for pilot testing. And that's I'll just talk to that in a minute. Next slide, please. This is just a kind of a snapshot of one of the screens on the tool, but it's a tool that we were using within the working group to illustrate how to do this financial analysis. It does include ways of discounting the cash flows, capturing non-energy benefits, and placing a value on emissions reductions. So we are looking for organizations to help us pilot test that. So if you are interested, please send an email to the email there on the screen. And if you don't get that email yet, when the slides come out, you can grab it from there too. But please let us know if you're interested in giving this a spin. Next slide, please. So what we want to do, we've got a poll, or three polls actually. Once you go to slido.com, and then once you get on there, you use the pound DOE, and you'll get the three poll questions. So the first poll is about learning more about you and your organization. And we're going to flip over to Slido and see what that looks like. So what sector do you represent? We just want to know where you're coming from on this. And so right now we can see, let's see that we've got a fair number of multifamily and contractors or consultants, but then further down we have higher education, local government, and industry coming in there, multifamily, other, and government as well. So we'll give this just another minute or so, or maybe 30 seconds to wrap up. Um, so that's great. We got representation from a wide swath of sectors, which is great. Okay, maybe we're ready to go to the next poll question. Okay, so now we're going to dig a little deeper into this. So when you think about how your organization evaluates energy projects and thinking maybe to more complex energy projects, do you use other metrics, or do you really just rely on the same ones over and over again, or do you apply more holistic metrics, which evaluate these non-energy benefits and take into consideration as much as you can? So right now it's coming out to, it looks like about a third are saying not familiar with this process or occasionally using the other metrics. And then maybe, I don't know, about 40% either sometimes or always use the more holistic approach. So that's a really good blend. And I think the fact that, we've got about 12 or 15% almost always incorporating the holistic metrics is really quite positive. Next slide, please. Or next poll, sorry. Yeah, so here we're going to dig even a little deeper. We're asking, do you always use a simple payback or a return on investment, or are you using discounted cash flows, or are you just not sure? And so, not surprisingly, simple payback is the top response. But it is encouraging that we do see right now about a quarter of you are using discounted cash flow methods, which we think is the preferred way to do more complex evaluations. And then about a third you're not sure. So probably some of those might be discounted cash flows and others more simple payback. And we'll give another a few seconds or so for a few more to come in, but I think we got pretty good response so far. Okay, about half on simple payback. So, but that again, that's pretty um, assuring that we have that many, about a quarter are using the discounted cash flow methods, and we think that will evolve over time. Okay, now we can go on to our next slides. Um, Now, first, I want to introduce our speakers. Um, And we have two speakers from the Better Plants program, two partners rather from the Better Plants program, speakers from those organizations, and them. So first we have Nick Harbeck of Johnson Controls. Nick is the manager of regulatory and environmental affairs at Johnson Controls. He previously worked as an industry analyst for the Air Conditioning, Heating, and Refrigeration Institute. You may know of it as AHRI. There he was modeling energy efficiency trends and atmospheric emissions of short-lived climate pollutants. Nick served as a member of the United Nations Decisions Task Force on Unexpected Emissions of CFC 11 and the FOAMS modeling team, and taught at George Washington University on the field of Monte Carlo simulations. And speaker two after Nick will be Aditi. Aditi Ilanthodi. Aditi is the sustainability specialist leading the Better Plants project at Weatherford, where she specializes in decarbonization initiatives and energy efficiency projects across global operations. Her expertise in energy modeling and data-driven sustainability solutions. She was certified as a lead green associate and holds a master's degree in sustainable systems from UT Austin. Thank you both, Nick and Aditi, for joining us today. And now I'm going to turn it over to Nick.
Thank you very much, Paul, and very good to be with everyone today this morning. Hope you're all doing well, whatever time zone you're in. Like Paul mentioned, my name is Nick Harbeck, and I work for Johnson Controls, which is a large manufacturer of heating and cooling equipment, as well as the connection for buildings to make them more sustainable, healthy, and a better place for everyone to live. So we have a few slides to go through today. I think we'll start with the intro and the agenda. And just wanted to give everyone an overview of who Johnson Controls is, what we do, and how we actually incorporate some of these holistic financial metrics that Paul has been talking about. And then we'll dive into 2 case studies, really focusing on how we can incorporate some of those non-energy benefits that Paul mentioned related to a quality improvement case, and then maybe a more long-term view of how we can incorporate financial metrics in a solar carport. We'll then close out with some key takeaways before I hand it back over to Aditi. So we'll go on to the next slide. And just to give folks a little bit of background, in case you don't know, Johnson Controls is a large manufacturer focusing in the building space. We make smart, healthy, and sustainable buildings, and we've been operating sustainably as a way we do business for many years now. We operate across many different sectors of the US and the globe, and really between the products that we manufacture and the open blue digital solutions that we serve, our customers have been able to achieve pretty significant energy savings and quality improvements, both in terms of employee satisfaction when it comes to the comfort of your building and actually the performance of products that get manufactured across the US. We have a few accolades which I've tossed up on the screen, but really this all relates back to the way that we do business. And you'll see this in some of the case studies today. We found it's been very important to incorporate more holistic financial analysis, especially when it comes to investments within both the buildings that we manufacture within and the products which we design. So if we go on to the next page, there's a little bit more background on how we've been able to incorporate some of those items, but really the highlights are off to the right. When we think about some of the aspects of the products that we manufacture, when I'm thinking about a large chiller that's providing heating and cooling in a way for our customers to reduce emissions, increase comfort, and make sure that they're more equitably using the energy grid, there are a lot of solutions that come out of the products that we manufacture, and it relates back to all of these holistic financial metrics that we're talking about. So we operate across many sectors. We continue to invest in new research and development, especially for new products that are coming out. And the way we do business with our products is also incorporated with how we perform financial analysis within our own operations. So let's talk about that a little bit. We'll go on to the next slide. And really the key here is that we take a fairly complex cross-functional approach to capital allocation and financing within Johnson Controls. When we think about creating a new project at maybe a particular facility, or as I mentioned in that research and development side of things, there are multiple avenues and multiple departments that get involved with that, and making sure that we're being effective in our communication and leveraging these multiple metrics help to get some projects across the finish line. We do that through a specific process called the capital allocation request process. It's fairly straightforward analysis, but I'm sure many folks are familiar with something similar, or maybe are hoping to move into this space. But we take what would be a simple financial payback period and incorporate a whole slew of matrices of decision-making, risk assessment, and opportunity assessments for getting projects across the finish line. So let's talk through that process a little bit, and then we'll get into some of the examples. So if we go on to the next slide, the CAR process really comes into play when we talk about capital expenditures. So for example, when we're working in a facility and maybe need to find opportunities to reduce energy consumption at that facility, the CAR process can help to get particular projects or energy saving opportunities funded within Johnson Controls and then executed throughout the course of the year. A certain threshold does need to be met, so this tends to be larger projects, and then a whole variety of metrics then get assessed and rated according to a matrix decision point. And that ends up resulting in point allocation for each of the categories that you see. So up top, we have carbon dioxide savings, but we also include things like the ability for a project to deliver Johnson Controlled growth, strategic opportunities for maybe new products that we want to manufacture, sustainability writ large, maintenance of those products and the buildings, and then regulatory compliance. And as we complete this CAR process, there will be things like Paul mentioned, like the simple payback period or a return on investment. But then we complement them with things like net present value analysis and these point weighting gradients for maybe incorporating some of the less quantitative metrics, but still have an outsized impact on either the energy consumption of a product, the quality of the product being manufactured, or the safety associated with a change in how we do business within our facilities. Generally, the points are rated on a 0 to 25 point scale. And by the time you do the risk and opportunity analysis for each of these topics, again, including carbon dioxide savings, growth, strategic opportunity, sustainability, maintenance, and regulatory compliance, you get a final score that gets added into that analysis. That ends up becoming really powerful. By having a high score in carbon dioxide savings, for example, that can help to push a project over the edge and getting funded for what would normally be, maybe not as attractive from a simple payback period perspective. And these thresholds can always be unique to your particular business or industry. For us, we find the threshold for carbon dioxide savings, for example, to really kick in at around 4%. So as soon as you start to see that, that's when projects start to get points for CO2. And as they increase the CO2 savings compared to a baseline, the points go up there. Same thing sort of applies for the other categories. So if there is an opportunity to reduce the maintenance costs on a particular aspect of our manufacturing, our facilities, the more savings you can achieve, or maybe the less downtime you can experience in that maintenance improvement process, the more points you get there. Ultimately, those two aspects get pulled together. So the financial analysis with more of the quote unquote hard numbers, and then these point scorings. And then we prioritize projects based on the ratings of each of this analysis. So for a very easy one to understand, if there is a regulatory compliance requirement, that will often shoot up our project to the top of the priority list, right? We're always going to make sure that we're following the law and doing things properly within our operations. And so those things get prioritized even higher than just some of the other aspects of how we do business. However, there are often many great opportunities to initiate a project that maybe has a more strategic goal for the organization. So maybe we want to work into a new type of product development, or we have a particular customer that has been requesting lower embodied carbon content, for example. Those sort of things help to rate up projects and, again, prioritize where capital allocation ends up going throughout the year. So we'll go on to the next slide and start talking about what that actually looks like in practice. So as an example, here's a quality improvement story. And the goal for this project that we had been talking about was finding ways to increase the throughput of chiller manufacturing within one of our facilities and reduce issues with quality of the product itself. At a very simple level, some of our products need to be cleaned after they are manufactured, and that cleaning is really important to making sure that they operate efficiently. When you're trying to heat or cool a building, any sort of issues with cleanliness can affect the ability of the efficiency of that product. So properly washing it and getting it out of the next stage in the manufacturing process is critically important to delivering on the quality that our customers expect. And so one of the things that this facility had reviewed was finding opportunities to improve the quality after that welding process occurred on some of the coils within our equipment. And then the washing station, which previously was just essentially a bucket of water that was constantly being flushed with fresh water. Those products would then be taken out, moved on in the manufacturing process. But the constant circulation, the pumping, the usage of all new water at all times, both used a lot of energy and a lot of water. And so one of the employees recommended that we look at a proposal to maybe install a sensor into that washing station and find opportunities to wait on flushing that water out until we achieve the optimal level of concentration of pollutant, or cleanliness within that system. So by doing so, the simple payback period analysis didn't really result in a reason for initiating this project, right? The cost of water in the United States is fairly low. The energy savings in terms of actual dollar value was not necessarily significant enough to hit thresholds for achieving a funding priority, but there were a couple of co-benefits that made us want to do this project. So the first was that by being more methodical and I'd say scientific in how we cleaned our products, the consistency of the product that was being washed was improved. So now our customers knew to expect a very specific level of cleanliness on that product, which corresponded in return to an actual increase in efficiency in those products in the field. So that was step one. That's one of those co-benefits. And then as a secondary and tertiary benefit, we were able to reduce water consumption by not needing to flush water constantly within that cleaning process. By not needing to flush and constantly pump new water in, we also reduced our energy consumption. So what once was a project that wouldn't necessarily meet the thresholds for a simple return on investment or a simple payback period, by adding these co-benefits, we were able to prioritize this project, improve the quality for our customers, and deliver it within the year and make sure that we are able to have our products have a higher throughput at a higher rate of quality there. It was really important in this scenario to incorporate everyone within the facility for input. In fact, in this case, somebody who wasn't even in the department was able to provide the input on this. And having those cross-functional teams, which I kind of mentioned earlier, are key to getting a lot of buy-in across the organization. I'm sure some folks on the call today are familiar with that, where you maybe have a few different departments or business units that are working towards similar goals, and finding ways to get those groups connected can be really important especially for projects that can result in energy savings or other savings that are a priority for your organization. So that was a nice non-energy benefit example, and I think we'd like to focus on an energy benefit example as well on the next slide. So another really powerful story is related to a solar panel installation project at one of our facilities in Oklahoma. At this manufacturing facility, there was a whole slate of redesign and energy saving opportunities that we've identified and went through, again, that CAR process. Now, for this scenario, we were able to couple multiple projects together within the CAR process to make a more compelling financial case. So like Paul mentioned earlier, incorporating more advanced financial metrics such as discounting, which is especially useful for these solar projects, with other aspects of facility energy improvements, we're able to do a whole slate of projects that ended up increasing the efficiency of the plant itself, reducing our energy bill and reducing our emissions across the organization. So this solar carport ended up being an attractive project because it was coupled with these other projects within the actual facility itself, such as changing the way that we use light bulbs, switching to high efficiency LEDs, swapping out to more efficient fans, blowers, and louvers within the air conditioning and ventilation system in that plant, and then finding opportunities to add co-benefits for the folks that actually work there. In addition to all the metrics you can see off to the right, you get the greenhouse gas emission reductions, you get energy savings, and then you have more reliable energy generation to the actual facility itself. There were some really interesting co-benefits that was nice to highlight to customers or vendors that came by to visit the facility. Obviously, in Oklahoma, it can get very hot. So having these solar panels over the parking lot added this nice benefit of legitimate shade for everyone that parked there, and sometimes, very importantly, a hail shield. It can hail pretty aggressively down in this part of Oklahoma, and by adding these solar panels, which undergo regular maintenance to ensure that they're producing enough electricity, employees' cars are protected. So you get these nice benefits that are added on to what normally wouldn't be considered within a straightforward, simple financial analysis, and including these extra metrics, incorporating multiple projects within one setup helped to get this across the finish line. So this was, again, a very powerful story. If you happen to drive past the facility in Oklahoma, wave at it and say hi. So these are just two examples, but I think there are some key themes that approach from this. So if we go into the next slide, there are really three things that we wanted to emphasize. One, like I just mentioned, coupling those financial payback periods with business priorities can really help to drive projects. So finding ways to tie energy savings to the health or safety and well-being of employees, finding ways to incorporate energy savings with regulatory compliance, product quality, those can accelerate those projects. And again, we found it very helpful to have those prioritization matrices and the points associated with those changes. So if you haven't yet, maybe think about incorporating, a 0 to 25 point scale or whatever scale feels right for your organization to couple with the simple financial analysis. The second key point is that project readiness is really important for fulfilling unexpected demand. In many of these instances, we'll receive requests from plant managers, for example, saying, hey, I have some extra funding set aside that wasn't actually allocated for capital this year, but we'd still like to deliver on some energy savings or water savings or financial payback in these projects. And having kind of items in the hopper ready to go at the end of a fiscal year can be a really powerful tool for those plant managers to say, for my dollars that I have still in my budget, I can get X amount of energy savings, X amount of quality improvement, whatever that metric is that they're looking for. So, if you have the opportunity to do that pre-engineering analysis and have the budget with the project with its benefits ready to go, that can oftentimes fulfill that unexpected demand. And then finally, a really key important consideration is trying to find ways to be cross-functional. Again, if there are multiple business units that have different goals that are aligned, that's a really powerful tool for prioritizing a project. Like I mentioned before, we'll have folks across our environmental health and safety business, our sustainability business, which I work in, real estate, operations, and often we're all kind of working towards the same goal of trying to reduce cost and increase quality of product, increase safety, increase our regulatory compliance mechanisms. And then working with those teams to appropriately rate the risk and opportunity analysis, again, on that 25-point scale, helps to prioritize those projects and make sure that everyone has a seat at the table for getting those funded. So those are a few key takeaways. With that, I think I'll hand it over to Aditi, and we'll take questions in a little bit. Thank you.
Great. Thank you, Nick. Thanks for stepping us through how you look at those. That was great. So just a quick reminder to go to www.slido.com if you have any questions, and we'll address them after we're done with Aditi's presentation. So without taking any more of our time, Aditi, let's hear what you want to cover with us. Thank you.
Thank you, Paul. Good morning, everyone. I'm Aditi, and I work as a sustainability specialist at Weatherford International. We're a multinational energy services company with manufacturing operations and integrated services across multiple countries. And today I'll be speaking with you about our journey in energy and emission reduction and our learnings in aligning financial strategy with decarbonization momentum. Next slide. In 2023, we formally enrolled into the US DOE's Better Plant and Better Climate Challenges. And since then, our main focus has been to set up energy efficiency as our foundation for decarbonization. Our goal is to then make projects that come a lot more financially viable and make the emission reductions boost further, given that energy efficiency is set up as the foundation. And at the time that we started ranking our facilities in the hierarchy of their scope 1 and 2 emissions intensity, across the company, there was a focus on viewing all our operations, processes, and projects through the lens of efficiency, which led to projects in building footprint consolidation, optimization, and it helped analyze efficiency in all processes, which then helped drive scope 1 and 2 emissions. But when we started working on these projects across energy efficiency, one of our main learnings was how important it is to tie robust financial metrics to each opportunity that's identified. It's one thing to identify an opportunity, but we noticed that it only gains traction and actually goes into the implementation phase when all of its benefits are transparent and visible to the stakeholders involved. Next slide. And so our first approach to financial analysis of each opportunity that we identify through these energy assessment processes across facilities was the techno-economic analysis, where we evaluated CapEx, OpEx, the ROIs, the payback period, and any other applicable financial incentives that come in through your utility, federal or state incentives that are attached to some of these projects. The other approach that we took along with the TEA analysis is once we identified these metrics for each project, we tried to group all projects together to develop a portfolio-wide metric. And that significantly helped us push projects across the finish line because looking at a grouped payback period or some of these other metrics often helps evaluate the project as a whole and push some of those projects that are slightly higher up in terms of technical feasibility or financial feasibility through the finish line when you view it as a portfolio mechanism. So that was one of our approaches. The other idea that we came across when there was a specific project that had a high CapEx, and there was a little bit of a pushback on implementation, was to identify what other external financing options we can consider. And one of the financing options that we did avail was the energy efficiency as a service, which essentially helps you convert your upfront capital expenditures into a more of an OpEx process. And so that is definitely one of the benefits that came out of this process in identifying projects that have high energy saving opportunities, but at the same time have high costs, were then put through that system of looking into other external financing options. When we look at projects that are more so in their nascent stage or still in the design phase, that's when we start looking into the life cycle cost assessment metrics, which then provides us with a more holistic view of long-term financial performance. So that has been our approach so far. And while the technical economic analysis framework is instrumental in identifying actionable opportunities at a granular facility level, we've also adopted a complementary top-down strategy to embed sustainability across all layers of our organization. Next slide. So before we move into what those opportunities look like, I wanted to give a quick example, probably something all of you have done with various projects across your organization, not just sustainability, but one of the tools that we used in this process was the measure tool offered by the DOE, which is available for everyone to use. And it really helped us quantify the technical aspects of a project. So identifying the baseline condition, identifying the modified condition, and what are some of those operational expenditures that come out of certain projects, such as a lighting project or a compressed air project, and so on. So then we associated some of these metrics, attached it to each opportunity, and then developed that grouped portfolio-wide view, as I described earlier. But moving on, like I mentioned, other than the technical and economic analysis, we also tried to identify this top-down engagement strategy. Next slide. So the idea was to collaborate with cross-functional stakeholders, such as teams from real estate, health and safety, operations and maintenance team, right from the shop floor to the facility managers, the senior vice presidents, and so on, and engaging all of them to increase visibility into the financial performance, but also those other non-energy benefits and the sustainability improvements that we were making as we identified these projects. And that has been pivotal in accelerating both interest and execution, because the transparency not only drives buy-in, but also motivates departments to scale successful initiatives and broaden their scope. So one of the most effective outcomes of this visibility was the introduction of tailored sustainability targets at the facility levels, and tying them with direct alignment to individual performance metrics. So that relationship then helped push projects to the finish line as well. And this engagement extended beyond the sustainability team. We noticed interest from other teams, specifically this real estate bullet train initiative. The bullet train is our organization-wide cost optimization program, which noticed financial benefits coming out of some of the sustainability projects. And that helped us promote a culture of continuous improvement, get that additional buy-in and support, and embed sustainability into the overall strategy across departments. Next slide. And then I'd like to quickly highlight some of the key data sources, tools, and programs that have supported our financial analysis of efforts. For cost estimation, we generally collaborate closely with facility teams and external vendors to capture and validate labor and material costs. That bottom-up approach generally ensures we develop accurate site-specific financial estimates for proposed projects, which then strengthens our business case and enables more precise analysis. And additionally, we leveraged utility incentive programs to support ongoing improvements in some of these facilities, which then boosts our financial metrics as well. One example is the Energy program with Clear Result, and they provide continuous improvement opportunities with a small incentive that then is reinvested into your continuous opportunity identification and implementation. And it's worth noting that there are several other utilities that do so: Centerpoint, Entergy, CPS Energy. So feel free to explore these opportunities because they could help push some of these projects through the line. And then for the energy efficiency as a service opportunity that I mentioned, we greatly benefited from looking through the Better Plant's website, where you could look at who the financial allies are, what sort of financing options they offer, and if that aligns with what you have within your project portfolio. Next slide. This summer, we initiated a focus project to develop a marginal abatement cost curve. For those of you who haven't heard of one, it's a graphical tool that's used to rank different projects and prioritize them, not only by cost, but also your emission benefits. So the bar that you see here, the height of the bar is the unit cost, and then the width of the bar is how much you can abate in terms of emissions. And the usual approach to building out a MAC is to obtain data from project levers that have been implemented already, and then evaluate how they compare to prioritize future opportunities. So we did develop the past or the current MAC, as we call it. But in addition to developing a MAC based on actual data we analyzed, which came from approved capital projects that were sent into the system we call AFE, we also developed, in addition, a predictive MAC. And this was a data intensive process. It involved identifying all capital projects across facilities, bucketing them into the specific levers you see here, such as energy efficiency, fleet consolidation, and so on. And while building a present time MAC is fairly straightforward once the data gaps are covered, developing that future looking predictive map involved having conversations with stakeholders, understanding their appetite for specific levers, and making estimates based on existing conditions and facilities and what the future potential could hold. So this future looking map helps us visualize what amount of emission abatement is necessary to close that gap to our goal and minimize resorting to methods like carbon credits, which probably is the last solution for us. So the goal is to ensure that the future MAC is dynamic and consistently updated based on the evolution of projects in the space. So it's crucial that we leave it dynamic and we make updates to it because we've also not considered some macroeconomic conditions that could continuously change, the influence of which need to be captured also continuously. So we really hope that this approach will help us make a better holistic analysis moving forward with our projects. Next slide. And then in continuation to that MAC, one of the other things we are doing to develop a more holistic view is perform a feasibility analysis and a gap analysis of what data do we currently have to quantify some of these measures for each lever that we identified. And moving forward, understanding what is currently a constraint or a barrier to implementation. How could we make that more feasible by incorporating non-energy benefits to identifying how it could impact teams like health and safety, how could it impact productivity? And so that has been our approach to make the feasibility aspect a little smoother. Next slide. And so in closing, I want to emphasize the critical role of non-energy benefits throughout this process in reinforcing and sustaining the decarbonization strategy. So while much of the focus has been on quantifying energy and cost savings, the broader impacts such as extended equipment lifespan in our facilities, improved system reliability, reduced maintenance costs, and enhanced process efficiency, they've all equally been influential. And these benefits not only contribute to operational resilience, but also drive stronger stakeholder engagement by creating that shared value across departments. For our example, footprint optimization and equipment upgrades often led to improved workspace conditions, reduced safety risks, and outcomes that align closely with the goals of several teams like operations, real estate, HSE, and so on. And so Justify is another tool in addition to Measure that we looked at, where you can quantify some of those non-energy benefits. And in addition to that simple payback, you can provide some more insight to stakeholders on what are additional cost benefits that we see coming out of these non-energy benefits. So I do think one of the big learnings for us in this whole process has been that decarbonization efforts and cost reduction efforts generally exist in a mutually reinforcing cycle where one consistently accelerates the other. And the goal is to keep incorporating these additional benefits to make sure we keep our process dynamic. Thank you. Thank you for your time.
Thanks, Aditi. That was great. Let's see. So before we transition, open it up for Q&A, I want to encourage you to download our additional resources handout shared in the Zoom chat box. These handouts contain useful links to resources from our Better Buildings program and our speakers on today's topics. We hope you find that useful. Now we're going to move on to Q&A. So if you haven't done it already, please go over to www.slido.com and use the event code #DOE to submit and upvote questions. Now I'm going to look at those questions real quick now and bring up, start addressing them. Let's see. So the first one that came up that we wanted to tackle was what is the standard value for discount rates? And I'm going to ask Nick and Aditi about that, but I wanted to add what we look at there. Often organizations will use their cost of financing as a proxy for that. So if they're going to borrow money to fund the project, they might use that interest rate. Another way to do it for organizations that use equity as well as debt, they can develop a weighted average cost of capital, which blends the cost of debt and equity and comes up with one single rate. I don't know, Nick or Aditi, if you have, I know you sometimes use discount rates, whether you have any experience with those and what you guys use to submit those.
Yeah, Aditi, do you want to take it first?
From my experience so far, we haven't taken that approach yet, which is why I don't have too much clarity into how some of our other projects are assessed from the capital lens perspective with the discount rate and so on. So I don't have too much clarity to provide on that.
Yeah, it's a good question. I think we're probably pretty similar to Aditi in that it's not used in every single financial analysis. For the times that we do use it, again, I kind of mentioned this during my presentation, but solar installations are a pretty common way for us to incorporate discount rates. I think guidance from DOE is usually around 7%, or at least it was in kind of previous years' analysis, and we've been pretty closely aligned to that. So we've found that to be a pretty useful number, at least for indicative discount rates. So yeah, 7% is the short answer.
Thank you, Nick and Aditi. So this question, I think this is for you, Nick, for the CAR process, focusing on the decision matrix to help score the 5 opportunities you identified with points ranging from 1 to 25 points. Do you have a rubric to help guide the scoring, or is it subjective?
Yeah, that's a very important distinction. We do have a rubric. I think it's probably going to be specific and somewhat subjective to each organization. But when it comes time to actually performing that CAR analysis, there's this essentially big table matrix of metric on the left of how many things you get for it. So in the case of carbon dioxide, like 4%, 48%, 8 to 12%, 12% plus savings in carbon dioxide, and then the magnitude of the project itself. So, 0, 100 metric tons, 1,000 metric tons, 1,000,000 metric tons. And as you kind of go up in savings and you go up in magnitude, you increase the score of that particular metric. And it's similar for all 5 of those specific topics that I shared.
Thank you, Nick. So here's one for Aditi. To use the MAC, the marginal value of emissions, is it only for decarbonization or it can be used for other measurements? Was the question.
That's a good question. And I think it can definitely be used for other measurements as long as you identify what the x-axis or the width of your bar needs to be. It could be used for, let's say you have a metric to identify and quantify safety, for instance, then a safety project that involves a certain amount of cost, you could always put it on the MAC and see if it falls in the negative side or the positive side, and then prioritize your projects to decide. But again, I think with decarbonization projects, because there are cost savings, there is a negative section in the MAC. So I guess what you would need to identify is whatever project you implement, are there cost savings that come out of it? It could be any metric on the x-axis, but if there are cost savings, then it could fall on either end of the MAC, and you could prioritize projects accordingly.
Great, thanks, Aditi. Let's see. So here's a question, an early question that came in about discounted payback versus why not just use simple payback? Because there's a belief that discounted means has a bias against longer term and long payback projects. What our experience has been is that actually the discount rate actually recognizes cash flows that occur after the payback period. So a simple payback period will not consider those. So if you have two projects that were $100,000 each and they save $50K a year for 2 years, but one project, the $50K extends out to 5 years, both those projects will have a 2-year payback, but the one project will have $50K a year for every year thereafter. So with the discounted rate, that would recognize that. With simple payback, it would not. So I don't know, Nick or Aditi, whether you want to add anything to that.
Yeah, I'll maybe add one item. I think Aditi actually raised this. One of the powerful ways to incorporate discount rates that we found is when we take some of those capital expenditures and somehow find ways to turn them into OpEx, essentially, right? So if there's a $200 project, sure, you could spend the capital all in year one. But if you incorporate a discount rate and you maybe finance it over 2 years and you incorporate that 7% discount rate, your net present value is only $193 over the course of those 2 years. So that's a good way to find savings, essentially, for those larger projects that you can incorporate that discount rate into.
Yeah, and that's a good point, Nick. Obviously, you don't want to use a hammer when you can do it with your fingers or your hands. So in other words, if you can use simple payback and it's effective for your lighter or less expensive energy efficiency projects, that's probably going to be fine. And then maybe there's a threshold over which you cross where you need to do a more robust analysis using discounted means. Aditi, anything to add there?
No, I think that covers it. That's pretty much what we did with one of our projects that had a pretty high capex and was receiving some pushback. So I agree with Nick's description.
We did get a question here, and I think whoever submitted probably needs to provide a little clarity. There's a question about a multi-attribute process like AHP. I'm not familiar with that, although they're saying in a program like RedScreen, and RedScreen did come up in the financial working group about a tool that could possibly be used. So that if you want to provide some clarity around that question, we can try to tackle that. I'm going to move on to the next one. The question about the software used to develop the life cycle cost, whether you use the NIST BLCC 5, and if not, do you follow the NIST handbook? I would say that the software that we used to develop the tool was a modification of other software doing the life cycle cost. I would suggest if you want, we can share that source with you. And my email is lemarpl@ornl.gov, and it's in the slides. Just send me an email. We can raise that issue or talk about that offline. So the next question, this is more of a discussion one that's good. Have you embodied or examined embodied carbon in construction activities? And if so, are there any resources you'd recommend?
Yeah, I can maybe take that one. Yeah, this is a great point, and this is becoming more and more relevant over time. The short answer is yes, embodied carbon is pretty important. It's becoming more important. We find, with our manufacturing, we have to also provide embodied carbon data to folks. And collecting that information, we found it helpful to follow the TM65 standard published by SIPSI. But there are probably multiples out there for different sectors and industries. But that's been our starting point. Great question.
Great. Anything to add, Aditi?
We have looked at it from the construction perspective, from when facilities are at its nascent stage, about to be set up and going, but it's not been an integral part of our analysis. So I don't have too much to add in terms of what we've referred to, mostly building codes and so on, but we haven't incorporated it into our, let's say, manufacturing systems and processes.
Definitely seems to be a developing area, but a lot of attention coming to it. So, Nick, this is a question for you. That for the solar carport in Norman, how do you know how the panels are rated for hail? Will they be damaged in a hailstorm? Obviously, obviously, that's a benefit you had indicated. And my sense is that because hail, even though it's not common everywhere, but it does happen, is that's a general condition that the manufacturers evaluate their panels for. But anything else you want to add?
Yeah, I believe there's some UL standards that rate actual physical solar panels for resiliency against hail. But yeah, it was just one of those nice co-benefits that we happen to have for that parking lot.
Yeah. I could imagine that would be very painful if you got and find your car just peppered with, small dents from hail. So that's probably the employees there probably really appreciate that. So we just crossed over to the hour, so we pretty much got through all the questions. So thank you all for your time. And any additional questions, please follow up with us. But I want to thank Nick and Aditi for their time today. That was great. Thank you for taking the time to join us today. And thank you all for joining us. We had, I think it was up to 395 participants at one point.